For our Capstone project, my team and I designed 3D printed smart device repair tools for our sponsor, Red Wolf Technology, through our mentor, Scott Daly. Red Wolf Technology distributes Bamboo Labs 3D printers to local retail stores, allowing them to access their mobile app, Primo Print 3D, which contains a database of STL part files for the consumer to print. Our project will allow Red Wolf Technology to expand their library, offering a wider variety of STL options for their consumers to print. It includes an entirely new tool library that our team is designing files for. There is no tool library for smart device repair in the Primo Print 3D application. Our team developed and modeled affordable, reliable, and easy to manufacture 3D print files of tools. We analyzed the required functions given to us by our sponsor and then designed our first iteration of devices. We used tensile testing combined with FEA to optimize our prints. These are a couple of the pictures for the STL files, as well as their corresponding finite element analysis, or FEA. We're able to use this as well as our tensile testing to optimize our prints in both terms of infill percentage and support material. This is some of the verification data that we're able to find through our tensile testing. We're able to track the modulus of elasticity in both the horizontal and vertical orientations of the layer lines, as well as infill percentage, to see how that affected our part strength, to be able to understand how best to manufacture or print them. These are the pictures of our final projects, or our final parts, with the tweezers on the far left, as well as the pry tools that are next to it and the bit driver. These are all designed as tools to be used on the phones. The picture on the right shows two tool holders to organize and make phone repair an efficient job for the technician, as well as two 3D printable phone fixtures to be able to work on devices with our tools as well. Our team transitioned from SolidWorks to Onshape, adapting quickly to the collaborative CAD software to streamline teamwork and design sharing. Through the project, we enhanced our 3D design and printing skills, identifying effective design concepts for printing processes. Despite challenges in conducting FEA and tensile testing on PLA, we generated accurate data to optimize designs for strength, reduce support filament usage. Ultimately, we met all objectives set by our sponsor, Scott Daly, showcasing our dedication and effective collaboration.